Hello, my name is Dave, and today we're going to learn about measuring efficiency. By that I mean time efficiency. How fast is our algorithm? How fast is it going to run? And it seems like at first that the obvious way to determine how fast an algorithm runs is to actually time it. Take out a stopwatch and measure how long it takes until it finishes. And there are some simple complications with that, but then there are some very big complications. Like, what if I time my algorithm on one processor and you time it on a much faster machine? What if we have different processor speeds? I would like my measurement of how fast my algorithm is not to depend on whether I run it on my computer from 20 years ago or my computer in 20 years. Alright, I might also be concerned what if we used different programming languages, because maybe if I claim my algorithm ran faster than yours when I use a stopwatch, maybe all I really measured is that programming in C was faster than programming in Python. So we'd like to eliminate that variable. And it could also be, what if we coded in different styles? What if I used a while loop and you used recursion and so on? So there are many different complications, and it turns out there's a really elegant solution to this problem, which is that we can determine the inherent efficiency of an algorithm by specifically by determining how does the running time, the time for that algorithm to run, depend on the size of the problem. We're solving. How does the running time depend on the size of the problem we're solving? And we're going to see lots and lots of examples of that starting now. So let's write some code and let's take a look at how long it takes to run. And the nice thing about this is we don't actually have to time it. We can actually just look at the code and determine how long it takes to run. So I'm programming in Java and I'm working with arrays, but if you're familiar with Python and lists, this will all of the same reasoning will carry over. So here I wrote a method to determine, given an array, how long is it? How many values does it contain? And I did that by just asking that array what is its length. So now I want to know, does the time for this particular code, does it depend on how long my array is? Now, first of all, we should state something very important here. Obviously, the answer that I get back from this method depends on how long my array is. If I give it an array of length 10, I will get back 10. If I give an array of length 20, I'll get back 20. But the question is, how long did it take to determine that the length of the array was 10 or 20? In other words, does it take longer to determine the length of a long array than to determine the length of a short array? And it turns out that no, the time here does not depend on the length of the array, and therefore we say that the time is constant. Does not depend on the length of the array. We could vary the length of the array and it will take the same constant amount of time to determine the length. Okay, let's work our way up and try some other possible implementations here. What if we wanted to know, does the time for this method, does it depend on the length of my array? And we could stop and say, well, wait, the time to figure out that the answer is 10, that doesn't depend at all on the length of the array, in which case its time is constant. And yes, the time is constant here. But the real answer here is, who cares how long this one takes, right? Who cares? It's wrong. It's wrong. So if let me do that like this. When we talk about efficiency, we're assuming the algorithm is actually correct, right? So correctness is far, far more important than efficiency. So let's not get so obsessed with writing code that runs fast if it turns out that ultimately our code is incorrect. So we're going to focus on only determining the running time of correct algorithms. Alright, let's look at another implementation of this. And let's see, I'm going to wish I had more room, so we'll make some. But I think I will want this question still. Okay, so correctness is far more important than efficiency. And in this particular case, the time did not depend on the length of my array. So let's try implementing this another way. Suppose we use a for loop. And actually we have a counter. We use a for loop. And as we loop over the contents of the array, we increment that counter. We add 1 to the counter, and at the end we return that count that we computed. So we look at the first element and add 1, we look at the next element, add 1, look at the next one, add 1, and eventually we return the total. Does the time for that method depend on the length of the array? Well, it does, because if my array is length 10, we'll add 1 to my count 10 times. If my array is length 100, we'll add 1 to my count 100 times. That will take 10 times longer. So the time very definitely depends on the length of the array. And as an aside, we should note this is a terrible way to determine how many values are in the array, because clearly we knew how to find the length of an array, so why are we doing this loop in the first place? So in this particular problem, the time does depend on the length of the array. And actually it's going to turn out that the time is, roughly speaking, very roughly speaking, it's proportional to the length of the array, or we'll say the time is linear in the length of the array, which is actually more correct than saying it's proportional. It's only truly proportional in the limit. So maybe we'll make a note of some of these. So we've got constant, switch color there, we've got constant time, which means the time does not depend on the size of the problem. And we've got linear time, which means the time is essentially proportional to, although that's not technically correct, it's a good enough definition to understand linear running time. For now, time is proportional to size of problem. And what that means is that if I double the size of the problem, I double the time. If I have the size of the problem, I have the time, roughly speaking. Now, technically, if I double the length of this array, it will take twice as long to count up, but it won't take twice as long to initialize count or return count, so it's not truly twice as long, but I think that's a good enough understanding for now. Alright, let's try another problem. Suppose instead of counting the values in my array, I decide I would like to simply get the last value. So, get last value. How can I find the last value? Well, I'm going to return the value at, let's see, that would be if my array indexes started at 0 as they do in Java, then the last index is the length of the array minus 1. So this will get me the last value in my array, and the question is, what is the time for this one? I'm going to wipe this off the board since it's confusing me. Here we go. What is the time for this method? And my choices again are, is it constant time or is it linear time? Does the time depend on the length of the array? Well, I do access the length of the array, and I subtract 1 from that, and I find the array value at that position, but it turns out the time for this method does not depend on the length of the array. This is constant time. Time does not depend on the length of the array. That's because finding the length of an array, asking the computer for the length of the array, runs in constant time. Apparently it just knows that off the top of its head. Subtracting 1, that doesn't depend on the size of my array, although the answer will. Accessing the element in that last position does not depend on the size of the array. So even though, so I guess that tells us that the computer can just randomly access, that's why it's called random access memory, it can randomly access that last element, and no matter which element I access, the time does not depend on what the index is, which element I access. So it's not like the computer starts looking at index 0 and then 1 and then 2. It jumps right to that last box and gets the value, and because of that, the time for this method does not depend on the length of the array. Okay, good. Let's do another one. Suppose I want to determine how many times a particular value appears in my array. So we're going to count how many times this value appears in this array A. So let's see, if I want to determine how many times a value occurs, I'm going to need a loop. So I can loop over all the values. And I'm going to need to look at each value, like the value at index I. I'm going to check, is that equivalent to the value? And if it does match the value, well, then I've I found one, so excuse me, then I will add to some count. Count equals count plus 1 or count plus plus, which means I need a count declared, which should start out at 0, and at some point later I'm going to return that accumulated count. That will be the number of matches. Does the time for this method depend on the length of my array? Is it constant? Is it linear? Is it something else? And the answer is, again, it's linear in the length of the array, because if I were to double the length of this array, I would have to loop over twice as many elements, compare twice as many elements to value, increment count potentially twice as many times, get some total, and return it. Alright, I think we'll continue analyzing this method in the next video. I'll see you there.